Good morning, grade 9s. Today we are going to be carrying on with our patterns journey, and we are going to be looking at describing patterns. And what we're going to be looking at today is the fact that to describe terms in a pattern, we use the following notations. So if we look at that, we've got T1 over there is the first term of a sequence. Now, little side note there, a sequence is another name for a pattern. So if you hear me jumping between sequence and pattern, they mean the same thing. So T1 is the first term of a sequence. Then if I have something along the lines of T4, that would mean that it is now the fourth term of a sequence or pattern. So what we can say then is that Tn is the general term. So Tn is my general term. Okay? So that general term is referred to as that little n that we see attached to it. Instead of it being a number such as 1, 2, 3, or 4, it's n, and that is the general term and is often expressed as the nth term of the sequence. So now, a sequence does not have to follow a pattern, but when it does, we can write an equation for the general term. The general term can be used to calculate any term in the sequence. Okay, so once we have that general term, okay, we can find out any term in the sequence. All right. So for example, if we're considering the linear pattern, so I'm just going to write it down. I know it's on the page there, but I've got 2, 9, 16, 23, 30, and then so on. Okay, and they tell us that the nth term is given by the equation Tn, all right, is equal to 7n minus 5. Okay, so they've given us the equation over there. And what we want to do is we want to see what happens if we start substituting values into the place of that n. Okay, so that n is my term number. So it could be anything. It could be the first term, second term, 10th term, 100th term. We can decide. So now if I go along and I substitute in, so I'm going to go and say, all right, so if 2 is the first term, 9 is the second term, 16 is the third term, 23 is the fourth term, and 30 is the fifth term, okay, what I'm going to do is I'm going to substitute these numbers into the place of n. If I substitute 1 in, I get 7 multiplied by 1 minus 5. So 7 times 1 is 7, minus 5 is 2. Same thing applies with the second one. If I substitute 2 into its place, 7 times 2, 14, minus 5 is equal to 9. 7 times 3 minus 5, 16. 7 times 4 minus 5, 23. And 7 times 5 minus 5, 30. So what we can see here is that when we substitute in a number in the place of n, we can calculate any term in the sequence. Alright, and that's proven by what we've just done now, is we've taken our pattern and we've substituted in our terms 1 through to 5, and it's given us the exact same answer as our pattern that we see there, or as our sequence. Alright, so if we'd go along, it says there that if we find the relationship between the position of a term and its value, we can describe the pattern and find any term in the sequence. A linear pattern is a pattern where there is a constant difference. Okay, so that constant difference is what we're going to be focusing on today. That constant difference between the term and the term before it. So if I look over here, I say A is equal to T2 minus T1, not the other way around. So if I go back to my original pattern over there, so Tn equals 7n minus 5. So I said that I got, for T1, I got 2, and for T2, I got 9. So now according to this rule, I say A is equal to T2, which is 9, minus T1, which is 2, which equals 7. That means that A is equal to 7. Now if you look carefully, you can see that this A over here is the same as this 7 over there. So that A value over there is the same as the 7 in the equation that we were given earlier. That means that that 7 is telling us that there is a constant difference throughout the pattern. What we're going to look at is patterns with constant differences between the terms. So we're going to jump into it straight with an example. Okay, so the example says the sequence is 3, 8, 13. And this is represented in a table. So the position, okay, so now look at the notations that we're using. So position is represented by n, 1, 2, 3, 4, 5, nth, okay? And then the term, which is the Tn, is represented by parts of the pattern. So in this case, 3, 8, 13, 18, 23, and then the equation of the pattern, which is 5n minus 2. So it says there, in the top row, n is the position of each term, and the bottom row, Tn, is the actual term in that position. Alright, so that is very important to see there. So first term in this case is 3, the second term is 8, the third term is 13, and so on and so forth. Alright, so when we look at this, it says complete the following using the notation T1, T2, T3. So what that means is we want to go and we want to jump into the answers over here. So basically how we would do this is in the place of those brackets we want to put in our values. So we want to put 1, 2, 3, 4, 5, and we want to get our answers over there. So we want to prove that our table is correct. So 5 times 1 is 5 minus 2 is 3. 5 times 2 is 10 minus 2 is 8. 5 times 3 is 15 minus 2 is 13. 5 times 4 minus 2 is 18. 5 times 5 minus 2 is 23. And then if you go and you substitute n into your equation, you'll actually get your whole formula. So 5 times n is 5n, and then minus 2, because I can't do anything further because they are unlike terms. So then the second question says, describe the number pattern by comparing consecutive terms. Okay, so what does consecutive mean? So if we break that down, consecutive means it flows one after the other. So what is happening when we're looking at the Tn, so the actual term in the position, all right, of this pattern, what is happening between each of them? Well, if we just write it plainly as we see it, we can see that we are adding, okay, so we are adding 5 to get to the next term. Alright, so we are adding 5 every single time between each of the terms. We're going to calculate the value of T50. Now remember, the n attached to the Tn refers to the position. So they have given us this n as 50. So we need to find out what actual term is at the position of 50. So how we go about doing that is we're going to go and we're going to substitute into our formula. So we know that this is Tn equals 5n minus 2. So now they say, well, T50 is equal to 5. Now in the place of n, we're going to put 50 minus 2. So that means that T50 is equal to 5 times 50 is 250 minus 2, which makes the actual term number at the position of 50 248. Then the fourth question there says, question 4 says, what is the position of 313 in the sequence? Now this is a little different because what we're going to be doing here is we're going to be saying, alright, so they've told us what the Tn is actually equal to. So they've said that Tn is equal to 313. And we need to find out the position. So we need to find out n on its own. So that means that how we go about doing this is we substitute 313 into the equation equal to my formula of 5n minus 2. And now we're going to be solving for n. So now I'm going to move this 2 over. So it becomes 313 plus 2 equal to 5n. So that means I'm going to get 315 equal to 5n. And then to get n on its own, I'm going to divide by 5, and I get n equal to 63. So that is now the position. So at the 63rd position, the actual term will be 313. Alright, so now let's jump into example 2. Example 2 says the table shows some input numbers with a few corresponding output numbers. So 1, 2, 3, 4, 5, 10, 20, 35, and then it gives us the nth, which is 4n plus 3. So this is my pattern general term. So it says there, starting with question 1, complete the table. So how we're going to complete the table is we need to find out what our values of 5, 10, 20, and 35 are going to be. So how you go about doing that is a simple case of substitution. So we know the formula. The formula is Tn equals 4n plus 3. So now we need to just substitute 4 values in. 5, 10, 20, and 35. So if you go along, so 4 open bracket 5 plus 3 is equal to. So 4 times 5 is 20 plus 3 is 23. So we can fill that in. Then 4 open bracket 10 plus 3 is equal to 43. So we can fill that in. 4 open bracket 20 plus 3 is equal to 4 times 20 is 80 plus 3 is 83. And then 4 times 35 plus 3 is equal to, well, 4 times 35 is 140 plus 3, which makes it 143. Okay, so now we've filled in the table, or we've completed the table. Second one says, what is the corresponding output number if the input number is T52? So this is exactly like what we did in the previous example. So they're asking us to find out the actual term number, or the actual term value at the position of 52. So now we're going to say T52 equals 4 open bracket 52 plus 3. Okay, so 4 times 53 is 208 plus 3. So now if you plus those two together, you get T52 equals 211. So at the position of 52, you have an actual term number of 211. The third question says, explain the relationship between the input and the output numbers in words. So if I have to explain the relationship, I'm going to see, okay, cool, I'm going to break down my general term into words. So if I break down my general term into words, I'm going to first multiply the input by 4 and then add 3. So every time I want to find out how I get to the next term, I'm going to multiply the term number by 4 and then add 3. And then the final question says, express the relationship as a flow diagram. Okay, so if I have to do this as a flow diagram, I'm just going to do this right over here. So I'm going to have my input. Okay, I'm going to have my input and I'm going to have my output over here. So my input is my n value and my output is my Tn value. So what needs to happen is any number that goes in needs to first be multiplied by 4 and then 3 needs to be added, and that will give you my output. That is it for today, grade 9s. I hope you have a great day and that your lockdown is going well.